All right, now for question 6, we have these two buggies, and they're going to run into each other because one's moving backwards and the other's moving forwards. Once again, I should have been clear that these are constant velocity buggies. So we're going to get linear plots when we plot their position versus time later on. The equation for buggy A, again, the general formula when we're moving at a constant velocity is x equals v naught t plus x naught, where this is a linear plot. This is the vertical axis, this is the horizontal variable, that's the slope, and that's the intercept, where the slope is the velocity and the intercept is the initial position. So we have x equals, for buggy A, it's moving backwards times t plus its initial position of 200. That's just the equation of its motion. For buggy B, we will write down its equation. It starts at the 40 centimeter mark and moves at 30 centimeters a second. So we have x equals, this is for buggy A, and for buggy B, we will have 30 times t plus its initial position plus 40. Excellent. Now, what we're going to do is use A and B to determine when and where the time and the buggies meet. So, and where they meet. So we actually did this lab early in the year. And so they meet at the same place. That's what it means to crash into something. It's when you're trying to be in the same place and at the same time. So I actually set these equal. And I solve. So negative 20 times t plus 200 equals 30 times t plus 40. Now let's continue. I'm going to add 20t to both sides. And that's going to give me 0 plus 200 equals 50t plus 40. Next, I'm going to subtract 40 from both sides. And that's going to give me that 160 equals 50t. Finally, I will simplify. I get that t equals 160 over 50. And when I actually simplify that, I'm going to get 3.2 seconds. I'm like absolutely sure I have that right. Okay? So. Let's double check something here. All right, and let me try one other thing. Okay, that's looking good. Now, that's the time that they're going to meet. And now to determine where they will meet, I'm going to substitute. I can substitute it into A or B. I'll substitute it into B. So xb, the equation is 30t plus 40. And I'm going to go ahead and put 30. And then I put in my answer from here in for the time, plus 40. And when I end up solving that, I'm going to get that xb is 136 centimeters. So they will actually meet at the 136 centimeter mark. Okay? So I think what I want to do is I'm going to actually take a look at part E on the next page, but I want to write down these equations here, so I'll have these available to me. Because I'm going to actually copy them onto the next page. And you know what? I don't like that. I'm going to use a different color for B. 30t plus 40. Excellent. So I'm going to take these two equations and I'm going to copy them onto the next page because I'm going to do this graph right here. Excellent. So I want to plot both of these equations. And you know what? I actually might move these equations to an easier to see location. So let me just zoom out a little bit so I can see the whole page. Does that work? A little bit more. There we go. So I've got these equations. I'm going to move them here so that I can go ahead and plot them. So let me just count some squares here. So I've got 1, 2, 3, so let's see. I think I'll count up by 10. So this is 20. And this is centimeters, of course. 20 centimeters, 40, 60, 80, 100, 120, 140, 160, 180, and then finally 200 centimeters. And then here, let's just see. Maybe I'll just go 1 second here. I'll count by 4s. 2 seconds here. And then 3 seconds here because I need it 3.2. So I'm just going to kind of spread it out a little bit. So that's like 0.5, 1.52, 2.53, 3.5. I'll just kind of mark them here like this. And that's totally fine. Now, let's plot the position versus time for buggy A. It starts at 200 and our slope is negative 20. So I go over 1. By the way, 1 on this graph is 4 squares over. And then I go down 20 like this. Over 1, down 20. Over 1, down 20, right? And then over half and down 10, I suppose, like that, okay? So I'll connect this line here like this. This is not the best. Oh my God, that was terrible. Let me try this again. Oh, that was awful. Okay, y'all, this is going to be a bit rough. We're going to try this out. So let me just see if I can do this. So here. Close enough. I'm going to try to fix this just a little bit. Close enough. All right. And now let's plot. So this is the position for A. And now we're going to plot the position for B. Okay. And that's right here. Okay. So we're starting at 40 and our slope is 30. So we go over 1, up 20, 30 like that, over 1, up 10, 20, 30, over 1, up 10, 20, 30, over 1, okay, so 40, 50, 70, sorry, 80, 90, 100, that goes there. And then here over 1, up 10, 20, 30, and 1 up about here like that. So now when we plot the position versus time for graph B, we'll start here. That was a terrible drawing. This is not going to be good, so we'll just try this. So here we go. Trying to draw a line here. That's close enough. So, and what we see here is our intersection is about at 136 and 3.2. So about 3.2 and 136 is our intersection. And 136. So this graph definitely validates what our equations got us. So that is the answer to question number 6.